I'm going to go over some basic troubleshooting of the three-phase circuit I have here in front of you. We're just going to kind of go through and give you some scenarios of what could possibly be wrong in the case that the motor itself is not working. Now, I don't have any power on this. This is just set up just for the video, just for reference. So say for instance we get called out to a machine and the operator says that his motor will not start. First thing I like to check is anything that's easy accessible. This motor here could be tucked up in a hole and very hard to get to. First thing I like to check is our incoming voltage, just to verify that we do have voltage. The second thing I like to check is the fuses or breaker, if there's a breaker in place. You can check your fuses one of two ways. One, you can simply ohm across them and get your reading that way. Or you can flip to voltage, AC voltage, and you can read across them as well. Now if you read across them here and you do not have voltage, then it means your fuses are good. If you read across them and you do read voltage, if you read across them and you read 480 volts, then that means your fuse is bad. One thing I like to make sure of when I'm checking fuses is I make sure that I'm in the right range. See here we're in auto range. Auto range is fine as long as you don't touch the middle part of the fuse when you're checking it. But if you was to hold the fuse in your hand like this and check it, you'll get a good reading. But watch this. I'll still get a reading with I'm reading my hands. So this is why I like to put my range in manual range and go to a high range. This way we're not reading through our hands. And we're still able to read our fuse. Second option we could have is we could have a bad contactor. Our contacts inside behind this cover could be bad, not allowing the correct voltage to come out to our motor once it starts. You can simply check a contactor pretty much the same way you can a fuse. Just ohm across it. Take one lead and put it into your line side. Your line side is your side that your line voltage is coming into. And the other one, and put it in your load side. The load side is what you have your load on, such as a motor or things of that nature. And once you have your leads set up, you can simply press your contactor in and check across. As you can see there, the meter behind us is changing. And you can do it for each phase. I just showed you the scenario with the motor hooked directly to the bottom or the load side of the contactor. And what if we have an overload on the bottom of the contactor, as we do here? We can simply check it. It has an indicator here to see if your overload has been tripped. To reset it, you simply press your reset button and it resets your overload. This overload is also equipped with a normally closed set of contacts and a normally open set of contacts. The normally closed usually interloops with your coil to keep your contactor from pulling in. Now to check this overload, you simply just read across it. But first you need to make sure that you have reset. If it is tripped and this indicator is showing that it's tripped, you will read open across your legs. To check the resistance of an overload, you simply want to go to your load side of your contactor to the wire side where your motor wires are connected and just read across. You want to do that for each leg. Or we could have a bad coil on our contactor. Or we could not have any voltage at all coming to our coil, not allowing the contactor to pull in. To check the coil on a contactor, you simply just read across the coil. I do suggest taking one of the wires loose from the coil so you're not reading resistance back through something else. If you have another coil, normally close to the contacts or something like that. So we go to one side, which is A1, and the second side, which is A2, and we just simply read across it. Another thing that could be an issue is your start or stop buttons, or an e-stop. Your start and stop buttons have contactors on the bottom that could have possibly been bad or gotten contamination. To home your contacts out on the bottom of your push button, you simply do them the same way as you do your contactor. So read across here, and you want to press. Now, as you can see, once we release, we still have a reading. This reading is simply coming from our coil on our contactor. So if we was to take one of our wires here loose from the coil, we could get a good straight reading. You can see here is one of our wires going to our coil. So we'll check our contacts again. As you can see there, we have no resistance. There we can read across it. And you can simply check your stop button or e-stop button the same way. Now, e-stop buttons and stop buttons, of course, have normally closed contacts, so they will read closed once you read across them until you press the button. Then they read open. Once you've verified that everything else is in good working condition and you get to where you need to ohm out the motor, you can do it one of a couple ways. You can measure from the load side of the contactor. Now, if you have an overload, in this case, you can come to the bottom side of the overload and measure resistance there to your motor, or you can come to the load side of your contactor and measure resistance there. If you measure resistance from your load side, this will also help you determine if you've got a bad overload. The only issue with measuring from the load side of the contactor is you're reading through these wires. Now, your wires could potentially be broken inside of conduit and giving you a false reading. So for that, I recommend going straight to the motor and ohming out the motor.